Morning, children. Hello. Morning, children. Hello. Narmada.
Yes, sir.
Rani.
Yes, sir.
Oh, thank you, thank you. How the classes are going on? Is it useful to you? Is it useful to you?
Yes, sir.
Really? Really, it is useful?
Yes, sir.
Okay, okay. You should participate all. Actually, very minimum students are only participating. Please. Right, the sir will be going to teach you what's the
Electrochemistry Faraday's law.
Electrochemistry, Faraday's law. Children,
Students, previous class
Yes.
we seen electrolysis. What do you mean by electrolysis? What is the energy conversion in electrolysis? Do you know that? Energy conversion in electrolysis. Chemical energy is converted into electrical, or electrical energy is converted into chemical? That's why I am asking. Which one is converted into which? Listen. Here, they are taking an electrolysis. Electrolysis is a process. By passing electricity, the chemical reaction happens. By passing electricity, the chemical reaction happens. Then it is known as electrolysis. Electro means electricity, and lysis means to break. So here we may take the laws which cover the electrolysis. There is a quantitative aspects of electrolysis. Is nothing but here Faraday's law. What is that? Faraday's law. So we are taking here, that is Faraday's law. Faraday's law. Okay, listen. Before that, we are taking Faraday. What do you mean by Faraday? So here we are taking, that is Faraday. What is that?
I love you.
Okay. So what do you mean by Faraday? The charge of 1 mole of electron. So here 1 mole of electron carrying a charge is nothing but Faraday. So what do you mean by Faraday? That means the charge carried by 1 mole of electron. So listen here, the charge, okay, the charge carried by 1 mole of electron. So the charge carried by 1 mole of electron. 1 mole of electron. So the charge carried by 1 mole of electron is known as Faraday. And here it is denoted as M. It is denoted as M. Denoted as capital F. Okay. Now we may take the charge of an electron. You know that the charge of an electron. So what is the charge of an electron? Here we are taking the charge of an electron. Charge of an electron. The charge of an electron is equal to 1.6 into 10 power minus 19 coulomb. 1.6 into 10 power minus 19 coulomb. is the charge of an electron. So here for 1 mole of electron, so the charge carried by 1 mole of electron is nothing but Farad. So for 1 mole of electron, we may calculate here, we may take that is for 1 mole of electron. 1 mole of electron. For 1 mole of electron, how much? It is. Listen. For 1 mole of electron, we are taking this multiplied with that Avogadro number. So here we are taking that is 1.6 into 10 power minus 19 into Avogadro number. Because 1 mole contains Avogadro number of electron, so that it is 6.023 into 10 power 23 electron, so that we may get it is 96,500. Yeah, then it is 96,500. So it is 96,500. 96,000.
ஒன்னும் ப்ராப்ளம் இல்ல சார் உட்கார்ந்து டவுட் இல்லாம நான் உட்கார்ந்து
வெல்கம் மிஸ் வாங்க
சார் அத 8 மார்க் இல்ல ஏதாவது ஒரு ரெண்டு क्वेश्चन சேர்த்து காட்டுங்க பார்த்தா
So which is equal to 96,500. So we are getting that is 1 Faraday, which is equal to 96,500. 1 Faraday, which is equal to that is 96,488. 96,488. So we are getting 96,500. 96,500. So 96,500 coulombs. 96,500 coulombs. So 1 Faraday is nothing but 96,500 coulomb. So we are getting this 96,500. Now, so what is a Faraday? Faraday means the charge carried by 1 mole of electron, and it is denoted by capital F. And charge of 1 electron as 1.6 into 10 power minus 19. So that here for 1 mole of electron we are get this one. Now, so 1 mole of electron is nothing but 96,500 coulomb. It will be carries the charge. It will be carries the charge. So from that we may get what is that? 1 Faraday is equal to 96,500 coulomb. 96,500 coulomb, which is equal to 1 mole of electron. 1 mole of electron. Correct. So we are getting this formula. So we are getting this one. So 1 Faraday is equal to 96,500 coulomb, and which is equal to 1 mole of electron. Which is equal to 1 mole of electron. Now, here it is experimentally found. We are passing electricity for 1 Faraday. Then the mass of substances deposited is equal to 1 gram equivalent weight. So Faraday found experimentally. It is experimentally found by passing 96,500 coulomb of electricity, by passing 96,500 coulomb of electricity is nothing but 1 Faraday. 96,500 coulomb of electricity then the mass of substances deposited is equal to 1 gram equivalent weight. So mass of substances Mass of substance. Mass of substance deposited at the electrode. At the electrode is equal to 1 gram equivalent weight. 1 gram equivalent weight. Listen, you know the equivalent weight. What is the equivalent weight? And the equivalent weight is nothing but molecular mass or atomic mass by its valence. So the molecular mass or atomic mass by its valency is nothing but equivalent weight. So from this experimental value, we may get 1 Faraday is passed, 1 equivalent weight of substances is deposited. So how much current passed, how much will be deposited, that will be given by Faraday. So here we are giving that the Faraday's law. Faraday's law. So we are taking the next one. We are taking that is Faraday's law. Faraday's law. Okay. Listen. We are taking Faraday's first law. Faraday's first law. Faraday's first law. Okay. So what is the Faraday's first law? Here, the mass of substances deposited at the electrode. Mass of substances deposited at the electrode during electrolysis is directly proportional to quantity of charge passing through the electrode. So we are saying that is during electrolysis. During electrolysis, mass of substances deposited at the electrode, mass of substance deposited mass of substance deposited at the electrode mass of substances deposited at the electrode is directly proportional to quantity of charge passing through the electrolytic solution. Quantity of charge passing through the electrolytic solution. Passing through the electrolytic solution. Electrolytic solution. So it is the Faraday's first law. So what is Faraday's first law? Mass of substances deposited at the electrode, that is mass, is directly proportional to charge of we are passing the electricity. So mass of substances deposited at the electrode is directly proportional to quantity of charge passing through the electrolytic solution. We may write it here, that is mass of substances deposited at the electrode or liberated at the electrode is directly proportional to quantity of charge passing through the electrolytic solution. So it is directly proportional to, that is Q. So M is nothing but mass of substances. Q is nothing but charge of electricity. You know the Q. What is that Q? So Q is nothing but I ampere current and is multiplied with T seconds. So Q which is equal to I into T. That is charge which is equal to I ampere current is passing through the electrolytic solution in T seconds. Okay, so we may equalize here. So M is directly proportional to I into T. M is directly proportional to I into T. So we may equalize it. Then we may get that is a constant. So here M which is equal to Z I T. Now what is that Z? So what is that Z here? The Z is nothing but electrochemical equivalent. What is that? Here Z is nothing but, that is electrochemical equivalent. Electrochemical equivalent. Electrochemical equivalent. So we are taking that electrochemical equivalent. So M which is equal to ZIT. M which is equal to ZIT is the Faraday's first law. Faraday's first law, that is M which is equal to ZI into T. So here M is nothing but mass of substances deposited at the electrode while passing Q charge or I ampere current is passed through the T seconds. Then we may equalize, we are getting that as Z, then Z is electrochemical equivalent. Now we may define electrochemical equivalent. What is electrochemical equivalent? So we may take the electrochemical equivalence. Electrochemical equivalent. Electrochemical equivalent. What is electrochemical equivalent? Okay, you know that M which is equal to ZI into T. And here we are saying I is nothing but ampere, that is current in ampere. So when I is equal to 1 ampere, I is equal to 1 ampere, then T which is equal to 1 seconds. T is equal to 1 second. Then what will happen? So my 1 ampere current is passed through that 1 second. That is here, that is 1 coulomb of electricity. 1 coulomb of electricity. So 1 ampere current is passed through that 1 second is nothing but 1 coulomb of electricity. So 1 coulomb of electricity is passed through that. The mass of substances deposited is nothing but electrochemical equivalent. So 1 ampere current is passed through that 1 second. Then we are getting M equal to Z. So that here, what is the electrochemical equivalent? The electrochemical equivalent is nothing but, we are passing 1 ampere current at 1 second. Mass of substances deposited at the electrode is known as electrochemical equivalent. Electrochemical equivalent. Okay. Now this electrochemical equivalent, how will you get the electrochemical equivalent directly? So there is a direct formula here. The electrochemical equivalent. Electrochemical equivalent is nothing but equivalent mass by Faraday. Equivalent mass by Faraday. So that we are saying that is equivalent mass by Faraday. Then it is a direct formula to get the electrochemical equivalent. So we are saying that is equivalent mass of element. Equivalent mass of element by Faraday is nothing but 96,500 Coulomb is nothing but 1 Faraday. Then we may find out directly the electrochemical equivalent of any element. Electrochemical equivalent of any element. So, what is Faraday's first law? Mass of substances deposited at the electrode is directly proportional to the quantity of charge passing through the electrolytic solution. Okay, now we may take the next one, that is Faraday's second law. What is that? Here, that is Faraday's second law. So listen, we are taking Faraday's second law. Faraday's second law. So what is Faraday's second law? Now we may take further, that is the same quantity of electricity is passing through different electrolytes. What is that? The same quantity of electricity is passing through the different electrolytes. Mass of substances deposited at the electrode is equal to that electrochemical equivalent. So listen here. The same quantity of electricity, same quantity of electricity, same quantity of electricity is passing through the different electrolytes, is passing through the different electrolytic solution, different electrolytic solution. So here we are taking the same quantity of electricity is passing through the different electrolytic solution. The mass of substances deposited is equal to that electrochemical equivalent. Mass of substances deposited is equal to that electrochemical equivalent. So here the same quantity of electricity is passing through the different electrolytic solution. Here the mass of substances deposited at the electrode, mass of substance deposited at the electrode is equal to the electrochemical equivalent. So here the same quantity of electricity is passing through the different electrolytic solution. The mass of substances deposited at the electrode, mass of substances deposited at the electrode is directly proportional to mass of substances deposited at the electrode, deposited at the respective electrode, is directly proportional to the electrochemical equivalence. Is directly proportional to electrochemical equivalent. Electrochemical equivalent. It is electrochemical equivalent. Listen, here we may take electrochemical equivalent here. That is the same quantity of electricity is passing through the different electrolytic solution. The mass of substances deposited at the respective electrode is directly proportional to the chemical equivalent, not the electrochemical equivalent. Listen, we are taking the electrochemical equivalent and chemical equivalent. Chemical equivalent is nothing but the equivalent mass of substances. Equivalent mass of substances. Then electrochemical equivalent is nothing but we are taking while passing 1 coulomb of electricity, that is 1 ampere current is passing through that 1 second, then it is known as electrochemical equivalent. So here we are taking that is the same quantity of electricity is passing through the different electrolytic solution. The mass of substances liberated at the electrode is directly proportional to the chemical equivalent. We may take an example for this. Listen, we are taking 3 components. We are taking, listen, that is 3 components. That is, one is so we are taking the first compartment which contains that is a silver. Then it is contains that is a silver, so AgCl. And here we may take the second compartment, and the second compartment which is present, that is copper sulfate. Copper sulfate. Okay, and the third component or the third component it contains that is aluminum chloride, that is AlCl3. Now we may take an electrode. Here we are taking the electrode, that is positive and the negative electrode. So here we are taking the electrodes. Listen. Now we may take here the cathode. Here we are taking a cathode. So in this, we are passing the same quantity of electricity. We are passing the same quantity of electricity. So we may connect it here, and these two are connected like this. Then it is negative, and here positive, and negative, and here positive, and that negative. Now it is connected with this. Here we may connect a battery, and it is the positive, so that the positive, now it is the negative, so positive and that negative. So here we are passing the same quantity of electricity. Suppose we may pass 1 Faraday of electricity to that AgCl solution and copper sulfate solution and that AlCl3 solution. How much silver that will be deposited? So here what will happen? That is silver get deposited. And here copper get deposited, and here aluminum get deposited. And in this, you know that is the atomic mass and the valency. You know that here the atomic mass of silver. Here we are taking that is a silver. Then it is 108 gram. 108 gram. And here that is copper. And in the case of copper, it is 63.5. 63.5 it is atomic mass, and here we are taking that aluminum, and it is 27. So here we are taking gram atomic mass. So silver 108 gram, and that copper that is 63.5 gram, and that is aluminum 27 gram. Now the valency, we are taking the valency. So the valency of silver. So the valency of silver is 1, and for copper is 2, and for aluminum which is 3. Now we may pass the same quantity of electricity through the different electrolytic solution. That is 1 Faraday is passed through the different electrolytic solution. Correct? So we are passing 1 Faraday with 1 silver chloride solution and the copper sulfate solution and the AlCl3 solution, and we may get the chemical equivalent. So we may get the equivalent mass of your substances. So we may take that is how much gram of silver will be deposited by passing 1 Faraday of electricity. So how much gram? 1 Faraday of electricity is passed, then the mass deposited in the case of silver, then it is 108 gram, because the equivalent mass of silver, because it is valency is 1. So atomic mass by valency is nothing but 108 by 1. So we are get 108 gram will be deposited. So we may get here the 108 gram of silver that will be deposited. 108 gram of silver will be deposited. And in the case of copper, what is the atomic mass of copper? That is 63.5. 63.5. Now, how much will be deposited in the case here? The valency is 2. So 63.5 divided by 2. So for copper, it is only 31.75 gram will be deposited. 31.75 gram. For aluminium, atomic mass of aluminium is 27 and its valency is 3. So 27 by 3. So only 9 gram will be deposited. So here the same quantity of electricity is passing through the different electrolytic solution. So what is the second law? Here the same quantity of electricity is passing through the different electrolytic solution, like here AgCl and copper sulfate and aluminum chloride. The mass of substances deposited at the respective electrode is directly proportional to the chemical equivalent. Here the chemical equivalent of silver is 108 and the copper is 31.75 and aluminum is 9 grams. So this much mass will be deposited. So this is Faraday's second law. Students, we are taking in this session that is only Faraday and the Faraday's law. And beware of this electrochemical equivalent and the equivalent mass. Electrochemical equivalent is 1 while passing 1 ampere current into 1 seconds, or 1 coulomb of electricity passed, mass of substances deposited is known as electrochemical equivalent. Now, in Faraday's second law, what we are taught here, that is, when same quantity of electricity is passing through the different electrolytic solution, the mass of substances deposited at the respective electrode is directly proportional to the chemical equivalent. Chemical equivalent. So here mass of A is directly proportional to chemical equivalent of A. So that is mathematically we may take that is the second law, that is mass of A is directly proportional to chemical equivalent of A. So we are passing different electrolyte. So we are taking that is mass of A by electrochemical equivalent of A, which is equal to mass of B by chemical equivalent of B, which is equal to mass of C divided by chemical equivalent of C. Then it is the mathematical expression of second law. So we are taking that is Faraday. What is Faraday? And Faraday's first law and that Faraday's second law. So we are taking that is a Faraday. What is Faraday? The charge carried by 1 mole of electron is nothing but Faraday. And what is the unit of Faraday? We are taking Faraday as it is a unit. So 1 Faraday is equal to 96,500 Joule. And here it is experimentally found that by passing 1 Faraday of electricity, mass of substances deposited at the electrode is equal to chemical equivalent. Now, Faraday's first law, mass is directly proportional to the charge. So M equal to ZIP. And here Z is nothing but electrochemical equivalent. So what is electrochemical equivalent? And here that is mass of substances deposited by passing 1 ampere current in 1 second or 1 coulomb of electricity. So what is the unit of electrochemical equivalent? Here that is equivalent to mass. If you are taking that is gram, then gram by coulombs inverse. So gram coulomb inverse is the unit of electrochemical equivalent. Now we are taking the Faraday's second law. The same quantity of electricity is passing through the different electrolytic solution. The mass of substances deposited at the electrode is directly proportional to the chemical equivalent. Okay. Okay, students, if any doubts, ask me. 1 Faraday is equal to how many coulombs? 1 Faraday is equal to how many coulombs?
96,500 coulombs.
So M is directly proportional to Q. Is Faraday's first law or second law?
First law. First law.
M is directly proportional to chemical equivalent. Then it is
Faraday's second law.
by passing 2 Faraday of electricity, how much copper will be deposited? By passing 2 Faraday of electricity, how much copper will be deposited? By 1 Faraday, 31.75. 2 Faraday,
63.5.
63.5.
by passing 3 Faraday of electricity, how much aluminum is deposited?
27 gram.
27 gram.
And by passing 2 Faraday, how much aluminum is deposited? 1 Faraday, 9 gram, and 2 Faraday.
18.
18 gram.
18 gram.
That's it. Good. Thank you, students.